Merging with simulator in 3, 2, 1.
Hello and welcome once again. I'm your host, Ms. B. Okay, so I like to explain that the welder has to be comfortable and relaxed, okay? So when we practice, we want to practice good form and posture, you know? Think of holding a very uncomfortable position for 8 hours, okay? It's just not, you can't do it, okay? So the position of your weldment really can help you, okay? So for the most part, your weldment should be about chest high, you know, between the dent in your neck to the bottom of your ribs. And we also want, you know, the welder needs to be facing the weld straight on. Don't be to one side or another because this can also affect the placement of your weld. And then we want to also avoid fatigue. We want to bend our knees just a little, okay? And your shoulders should be relaxed and your elbows kind of near your sides, okay? This helps you to be more steady, okay? And once you're comfortable, everything just kind of like the stars align, whoa, and it goes. It's really cool. Okay, so use as much of the practice blade as possible. We want all sides to be used before we get any more material. Okay, now, stringer bead, or a stringer, or a bead, okay, is the basis for all welds, okay? Usually, this is a straight weld bead on a plate. This is where every welder starts out. And in order to perfect the skill of welding, a welder practices maintaining correct amperage, correct arc length, correct angle, and correct manipulation, okay? Stringer beads also assist setting up the welding machine properly. A stringer's run so the settings can be assessed and changed as necessary. Okie dokie, so slag. Slag is the coating on the outside of the weld, okay? It needs to be removed from the weld after each bead, okay? So to remove it, we're going to need a couple of tools. First, it's the chipping hammer. Now, do not use it like a hammer, okay? We want to use a chipping hammer by scraping across the top of the weld, okay? And getting the majority of the slag out. And then we use a wire brush or a wire wheel to remove the rest of the slag that's stuck in some areas. We don't want to hit or damage our weld while it's cooling or when it's red hot. And a lot of people think that the harder they hit it, the more they're going to get the slag off. And in reality, you're actually making little dents in your weld and you're prematurely fatiguing your weld itself and it can break. We don't want that. More slag. Okay, so let me define what the slag is, okay? Slag is a non-metallic covering created, okay? And they call it by slag-forming elements in the flux of the electrode, okay? Slag also protects the weld until it solidifies, and it protects it from atmospheric contamination. Slag also helps the weld cool slowly so it can be stronger and more ductile. And slag also aids in the shaping of the molten metal while it's cooling. Now, the added materials to the flux help pull like impurities from the metal and remove them through the slag. So 6010 is one of those that has a type of flux that helps remove our impurities. Now, slag can also be our enemy, okay? If the welder manipulates the electrode incorrectly, the welder can introduce slag into the weld. Now, this is called slag inclusion. Don't let anyone tell you that you can weld over the slag and there's no problems with it. Yeah, you can weld over slag, okay? But there is a consequence. And you could be making a slag inclusion. Now, if you're having your stuff, you know, being used by people, hey, it can break. So it's just better to clean the weld properly. And so we can see the slag removed here. And here would be slag inclusions, okay? It's in the weld. Okay, so let's talk about different types of welds. Okay, so there are really two major different types of weld joints. The first is the fillet weld. Okay, this is on the left-hand side. And the profile looks like a triangle. And I also put a little symbol in here, okay? This is the symbol for fillet, okay? And the symbol looks just like a triangle, okay? So when we talk about fillet, okay, this usually has a vertical and a horizontal. So vertical and a horizontal member that's welded. And most often, it's a T-joint, okay? Now, on the other half, this one is called a groove weld, okay? Just as it's called, it's a groove. Usually, members of this are on the same plane, so left and right, but they're both horizontal or vertical, okay? We need to remember that, okay? And then when we look at it, the profile of the groove depends on the edge preparation. So we're going to use a groove weld as an example. As we can see, here's the V, okay? Here's our groove, here's our V. Pretty cool, right? So I'm showing you these weld symbols so that you can actually get understanding and become comfortable with using the symbols. So here are the most common weld joints. Butt joint, okay? The members are butted together, okay? This is a groove. Lap joint. There's a lap joint. They are overlapped. This is a fillet weld, okay? T-joint, well, it looks like an upside down T, and this is also a fillet weld. Now, this one, corner weld, okay? It's a corner. Now, it can be considered a little bit of both, depending on the fit up of the corner, and we'll kind of talk about this later. And this can be a fillet or a groove. And then we're talking about edge. Well, just as it seems, it's a weld on the edge, and this is more or less a fillet. Okay, so the root opening. The root opening is the space. This is a root opening, root opening, root opening between two pieces of material, okay? Sometimes there's an edge preparation of the material and the metal can be in different shapes. But we need to understand that an improper root opening, being too tight, can not allow for full penetration. But on the other hand, if it's too big, you know, it makes the impression that it's going to fill the joint properly, but there's usually a lack of penetration because the weld could not be placed properly because the root opening was too large. So here it is, too small, too big. Okay, we want something that's correct. A lap joint. It is as it says, it overlaps another member. Now the joint can be welded on one side or both sides, unless otherwise noted. Both sides of the weld should be welded when we're talking about a lap joint. Now, so a lap joint's a fillet weld, right? So here's our, we can see our fillet now, right? Here's our fillet, okay? Now, when welded, the weld should be the same size as the thickness of the plate. Now, a good weld will have a smooth transition from the weld to the plate, and if there's an abrupt transition, it can cause stresses, and it actually weakens the joint. So in most cases, and this isn't, you know, rule, but it's not usually done over 1/4 inch thick material, but there are cases when it is done. So, you know, just keep that in mind. But if we look, here's our legs, and it's showing that it's the same thickness as our material. Okay, so complete fusion is really necessary for lap joints to be strong. The root of the weld, it needs to be properly melted to ensure complete fusion. If the weld pool kind of shows like a notch at the leading edge, and sometimes it's really kind of hard to show it, you have like a little edge, okay? And it's really hard to see. And this shows that the root's not really being fused correctly. So many times we need to manipulate the electrode so it can help it. So it's a lot smoother. So let me see if I can show you here. See how smooth this edge is? Now see how it's kind of like, and if we look carefully, just kind of sitting there. It's not really correct. Okay, so now we're going to talk about corner joint. Now, as I said earlier, the corner joint can be done in a couple of different ways. Now, the first one is the outside corner joint or full open corner joint. Now, let me show you where's my full open corner. So this would be something like this, okay? Now this creates a little V and you can weld in there. And there can also be a flush corner that's done as well. And this could also be called an inside corner. Okay, so we can look and see, oh wow, well I can have a J groove in here. Here's a half open corner. Here's my flush corner. So I would weld it interiorly and exteriorly. Okay, we can have a bevel on it. So there's many, many different ways to do a corner joint. T-joint. This is a very common joint. Okay, a T-joint is really an upside down T. In order to properly position the metal, you need to tack it. Now, let's understand this. A tack is a small weld that keeps the metal in the right spot. Okay, remember, your tack should be placed in an area that it can be easily welded over or ground smooth. After you make the tack, you need to remove the slag. Okay, if the slag's not removed, it can also cause a slag inclusion. So, in a T-joint, heat really doesn't distribute evenly among both of the plates. Okay, the vertical member or the stem, okay, this will heat up a lot faster than the base plate. So when welding and using a manipulation, most of the heat should be directed towards the base plate to keep the weld size uniform, prevent undercut, and it'll have a little bit more evenly heating. All right, a T-joint can be really strong if it's welded on both sides. Now, it's important that the size of both welds are the total thickness of the base plate to make it strong. What do you mean? Well, what is my thickness of material? And I want to make sure that my weld is comparable to that, okay? The bead for a T-joint should be flat or slightly convex to have the greatest strength. And remember, having too convex or too much contour can affect the stresses. So here we have the stresses, these little orange lines. Let me make this bigger for you guys. Okay, here's our stresses, right? And if I have a flat, it's kind of like smooth and kind of ripples off. Now, if I have something too convex, right, too bubbly, my stresses are being held up here at the toes, okay? And we can have cracks here and here. Not a good thing. All right, overall, in summary, shield metal arc welding is called stick and mow shops. It's really important to practice to develop your skills to be a professional welder. Okay, nothing's better to improve your skills by actually welding, cleaning the weld, taking a look at your welds, being critical of them, even though sometimes we don't want to be. And then we need to make corrections to make a better weld. You know, I know it's hard being a new welder, and sometimes it's really hard to concentrate past the sparks, but the skill will come with time and practice. As always, guys, take care and weld the world.
Please like and subscribe. If there is something you would like to learn about, please leave it in the comments.
Weld the world.